Alright, today we're going to be talking about the combined gas law. The combined gas law is interesting because it, as the name suggests, combines the other gas laws into one, or at least Charles, Boyle's, and Gay-Lussac's. For example, in a Boyle's law problem, it will give you a pressure and volume, it will give you a new pressure or a new volume and ask you to find the one that it didn't give you from P2 or V2, and it will say temperature is held constant. So in order to get Boyle's law out of the combined gas law, you just erase the temperatures, and all of a sudden you have Boyle's law. The same is true for if you wanted to get just Charles' law. Charles' law is a volume and temperature ratio, so you would just erase your pressures, and all of a sudden you'll have Charles' law. So the combined gas law can replace all three of those gas laws. So we're going to work through a combined gas law problem. These gas laws are often called before and after problems because you're given a set of information before a change and then a set of information after a change. So take a moment and write down this problem. Go ahead and pause the video. Okay, so in order to solve this problem, we'll need to use P1 V1 over T1 equals P2 V2 over T2. Because we're given a volume, a temperature, and a pressure. Just like with the ideal gas law, we are going to play it safe and always convert to Kelvin. If you happen to end up with a negative temperature in Celsius, it will give you potentially a negative volume or a negative pressure, and since you can't have either of those for these gas law problems, we are not going to include any degrees Celsius. They all must be converted to Kelvin. So, as I look, I see that my first pressure is 1.8 atmospheres, so it goes where P1 belongs. Next, volume 1 looks like it's 50 liters, so volume 1 goes where V1 is. And lastly, T1 is our first temperature. We're going to take 25 plus 273 to get our final temperature. That looks like it's going to be 298. Alright, then we look at our second pressure, and we have one. It's 0.855 atmospheres. And it looks like we don't have a second volume, so V2 will be the variable we're solving for. And our final temperature is 10 degrees Celsius. We add that to 273 to get Kelvin. From here, we solve it algebraically by cross-multiplying. So we'll multiply 1.08 times 50 times 10 plus 273, which looks like it's going to be 283. And we'll cross-multiply the others. Our 0.855 atmospheres with what will turn into our 298 Kelvin. And we'll get 15,282 on one side and 254.79 V2 on the other side. Now we need to isolate our V2. Since these two are being multiplied together, we need to divide to get rid of it. So we divide 254.79 on both sides, and our V2 equals 60 liters. However, 60 only has one significant figure, and the least number of significant figures we're given are 25, so we need to have two significant figures. By adding a decimal point, we make that trailing zero significant, and now 60 liters is an appropriate final answer. Alright, that's the combined gas law. Come in if you have questions.